Scientific evidence in the Big Bang. Now, are we being told all the evidence again? It seems that the Big Bang is almost a fact, based on what I read in textbooks. Well, let's look at the evidence. Evidence of the Big Bang. Here's some of your popular evidences for the Big Bang. The redshift of starlight, cosmic background radiation, element abundance, education system in the medium. That's some of their best evidence right there, education system in the medium. But let me show you the evidences that contradict the Big Bang. Redshift of starlight, cosmic background radiation, galaxy formation, spiral galaxies, supernova remnants, distribution of galaxies, first and second laws of thermodynamics, medium heavy elements, star formation. Wow. And we can go on and on there too. Did you know about 90% of the universe is missing? Anybody here take it? It's kind of cold, dark matter. 90% of it's missing. We can't find it. It's just not the matter we can see out there. See, as a creationist, we can take it or leave it, but the evolutionists have to have it for their model. So they're looking desperately for this dark matter. Well, I want to take a look at just one of these pieces here. We're going to look at just one of them. And I want to start with the Big Bang. What do we know about the Big Bang? What is this Big Bang? Well, here's your handy space answer book, 1998. 15 to 20 billion years ago, the Big Bang or explosion occurred, creating the universe. The universe began as an infinitely dense hot fireball scrambling in space and time. Now, don't get the idea the Big Bang is like a dynamite explosion. That's not the picture we have. The Big Bang is a hot fireball. It's an expansion of space and time. That's what it is. It's an expansion, a hot fireball expansion of space and time. It is not like a dynamite explosion. So we need to forget about that. Get that picture out of your mind. That's not it. So space and time is expanding. And there's some critical things this is going to be built on. The Big Bang model, expansion of space and time. Here's what we're saying. Here's our original matter. Where did that come from? It's a pretty good question. It is a legitimate question, too. And it gets ignored. Why? Because the evolutionists don't have an answer. Folks, if you don't have an answer, just say you don't have an answer. Don't ignore it. You're not being scientific then. Here's your original matter. And here's what happens. Space and time expands out. And then what we have is a universe with no center. That is critical to the Big Bang model. A universe with no center. Not many people ever read that, but that's part of the Big Bang model. It's kind of like, I'll give you a rough analogy. You got a balloon. You blow it up. You have all these dots on it, and as you blow it up, everything expands. And where are all the dots? They're on the skin or edge of that balloon. That is the universe. What's in the middle? We don't know. According to the evolutionists, there's nothing there. That's the model. And that is critical. Now, does this sudden introduction of matter and expansion sound something like a miracle? Well, let's see what Paul Davies has to say about it. He's a physicist and an evolutionist. In his book, The Edge of Infinity, he describes the Big Bang this way. The Big Bang represents the instantaneous suspension of physical laws, the sudden abrupt flash of lawlessness that allows something to come out of nothing. It represents a true miracle. Whoa. That's exactly what it is. The evolution model clearly relies on miracles here. Where did the matter come from? What caused it to expand? Because you know every effect has to have a cause. And there is no explanation for that. So it's being taught on a faith-based issue. So why is that any more scientific than in the beginning God created? Because there is no physical evidence where the matter came from, nor what caused it to expand. No evidence whatsoever. Will we find it? No, you won't. Because it's an historical thing. Can't be repeated. Well, let's go a little further. The Big Bang. Richard Goat, PhD in astrophysics. Implications of the Copernican principle. Anybody remember Copernicus? Did he preach heresy in his day? What did he say? The earth is not the center of the universe. And everybody got on top of him for that. But you know, that is part of the Big Bang model now. Two key things to understanding the Big Bang. One, it has no center. And secondly, it's homogeneous. Meaning, regardless of where you are in this universe, it's going to look the same everywhere. There is no special place in this universe. That is critical to the Big Bang. Here's what he says. The idea that we are not located in a special spatial location has been crucial in cosmology, leading directly to the Big Bang theory. So two things. No center, no special place. Means no matter where you're located in the universe, look out there, it will always look the same. Well, let's look at some of that. And I want to use this one, the redshift of starlight. That is popularly used as strong evidence for the Big Bang, that the universe is expanding. Now, redshift, light spectrum. Let me give you an analogy of what we're talking about. We've probably heard of something called the Doppler effect. Let me give you an idea of what we're talking about here, redshift to starlight. Because we have our light spectrum here. We have the ultraviolet one side, the blue side. We have the infrared, the red side. Red and blue sides here. Now, let me give you, let's say a car was approaching you, and its horn is on all the time. As that car approaches you, what happens to the sound, the pitch of the sound? It gets higher and higher, doesn't it? Why? Because the sound waves are being compressed as it's nearing you. But once that car goes by you and is going away from you, what happens to the pitch of the sound? It gets lower and lower because the sound waves are being stretched out. The same thing applies to light. If a light source is moving towards you, you will see it show up on the blue side of the light spectrum. It's not blue light. We're not talking about blue light or red light. It's just the elements will come down onto the blue side. But if a light source is moving away from you, it will show up on the red side of the light spectrum because the light waves are being stretched. Almost everything we observe in this universe is redshifted, which gives a very strong indication of a Big Bang back in history and everything is expanding. That's what we get in the textbooks. So, light source moving towards you, compressed. Light source moving away from you, stretched, red side. Redshifts are used to describe the expansion of the universe, the distance of a galaxy from the Earth due to the stretching of the light waves. That's what's in the textbooks. That sounds pretty good. Very convincing. Redshift interpretation. Let me give you an example here. If we saw a galaxy at this distance, it might show up on this side of the redshift. If we saw a galaxy further away, it would show up further to the right on the redshift. If we saw a third galaxy that was even further away, it would show up further on the red side. So that's what we're saying here. It's a measure of the distance of these galaxies. Now, if evolution is true, remember their model is based on what? Homogeneous universe. Everywhere we look, it should be the same. We should find these redshifts all up and down that light spectrum. All up and down. In other words, this is kind of what we should see. Redshifts all up and down that light spectrum. Everywhere we look, we should find galaxies on that redshift line, all up and down. But the fact, notice, the fact is that is not what we observe. What we observe is this. Those redshifts are coming in distinct quanta, distinct distances, at 1 million light year distances. In other words, we see a redshift at 1 million light years. We see another redshift at 2 million light years, another one at 3, and another one at 4, but we don't find anything in between there. They're coming what we call distinct quanta. And we look out there and we see these concentric circles around us. Let me give you an idea of what we're talking about here. There's our galaxy. That's the best PowerPoint can do there. There's our Milky Way. We look out there and we see a concentric circle of redshifts at 1 million light years. We look out a little further. We see another concentric circle around us of redshifts at 2 million light years. We look out a little bit further. We see a redshift concentric circle around us at 3 million light years. Has this been confirmed? Because it's going to have a very important part in this cosmology and the Big Bang. Has it been confirmed? Well, here's a couple of astrophysicists in their astrophysical journal back in 1984. Almost 20 years ago, this is what they said. There is now firm evidence that redshifts of galaxies are quantized, meaning we have them in these concentric circles around us. However, back in 1984, most people did not want to believe this. That can't be true. Well, here's some astrophysicists said it is. They've observed this. But the world said, no, we're not going to bother with that. Well, let's see a little further. Redshift. Russell Humphreys, PhD in physics in Technical Journal. I have his book back there, Starlight in Time. Incidentally, he is an award-winning physicist. Astronomers have confirmed that numerical values of galaxies' redshifts are quantized, tending to fall into distinct groups. That would mean the galaxies tend to be grouped in conceptual spherical shells concentric around our home galaxy. This is going to have great repercussions here. Let's look a little more here. Confirmation by the Hubble. Here's the 1997 Journal of Astrophysics and Astronomy. The redshift distribution has been found to be strongly quantized in the galactic concentric frame of reference. The phenomena is easily seen by eye and apparently cannot be ascribed to statistical artifacts, selection procedures, or flawed reduction techniques. In other words, what he's saying there, it has been observed. So well observed, the Hubble telescope has confirmed this out beyond 1 billion light years now. Wow. What does all this mean? What does it mean to the Big Bang? Well, Russell Humphreys puts it together here in his book, Starlight and Timing. The quantized distribution of galactic redshifts observed by various astronomers seems to contradict the Copernican principle and all cosmologies founded on it, including the Big Bang. In other words, the only way, the only explanation we have for why we can see concentric circles around us in the redshifts is that our galaxy has to be within 1 million light years of the center of the universe. I'm not talking geocentricity now, where the Earth is the exact center. We're talking galactic centricity, where our galaxy is near the center, can be moving, but it is near the center. The observable data supports that today. And this was founded by the evolutionist astronomers almost 20 years ago, and it has been confirmed by the Hubble telescope. What does that mean to the Big Bang? What did the Big Bang say? There is no center. And there's homogeneous universe. Well, it is not homogeneous, and there is a center based on the observed data. Isn't this great? Did anybody see this in the news? No, it is they're doing their best to hide this information. I got a lot of astronomy books at home. Not one of them mentions this yet. Implications. Halton Art. Now, he is a very big evolutionist astronomer. Extremely good astronomer. When he made some of these discoveries, they ostracized this man. In other words, if you go against the norm, they don't want to have you. That's not called science. Science is based on looking at all areas here. You see, if you go against evolution, they don't want you anymore. Here's what he has to say. The fact that measured values of redshift do not vary continuously but come in steps, certain preferred step values, is so unexpected that conventional astronomy has never been able to accept it, in spite of the overwhelming observational evidence. But what do we know about evolution? Evidence doesn't matter. All that matters is you believe. And if anything goes against your model, get rid of it. That's what we're seeing in the evolution model. But that's not science. We need to get back to thinking like scientists and acting like scientists, not forcing ideas. Implication, quantized redshifts. Summary of evidence is what we're seeing here. Evidence appears to purport the Big Bang only when contradictions are ignored. I've called our textbooks. The Big Bang model is constantly changing to match the data. The Big Bang model cannot explain much of the observed data. In other words, are the evidences for the Big Bang good enough to warrant billions of years of time now? Not at all. Because the observable data does not match Big Bang cosmology. The Big Bang, folks, is in big scientific trouble. It is being kept alive by the media and textbooks only.